So our radicals or roots can be shown as exponents and vice versa. We can convert this exponential expression into a radical expression. And we know that the denominator is the root and the numerator represents the power. And since roots and powers have no priority, it doesn't really matter if the power is on the outside or inside. So here I have my 27, and I'm going to apply my, let's apply the power. So again, I could apply the power afterwards. Okay, so there's my power. Actually, this is going to be, I should apply the root because I don't want to power the 27 to the power 5 first when I know I can do the cube root of 27. So I'm going to do the cube root first because that's going to be much easier to calculate when I have to calculate this. And then I'm going to apply the power 5 after. Okay. So here, when I apply this, then I have the cube root of 27. That becomes 3 to the power 5. Okay, and 3 to the power 5 works out to 243 when I multiply 3 times 3 times 3, or 3 to the power 5. Here we have a fifth root and a fifth power. Well, I can convert this to an exponent and calculate this, but I also know that these are going to undo each other, so I should end up with 32. And in fact, if I write this as a power, okay, I have my power 5 in the numerator, and I have my root 5 in the denominator. Okay, that works out to be 32 to the power 1. When I simplify that ratio, it's just 32. And that's what I expected because these will cancel each other out. And notice that they undo each other in the ratio. Okay, here we want to rewrite this as a root. Maybe we should, this says write an exponent calc. So maybe we should just deal with this as exponent because this is much easier to deal with as an exponential expression. So here I'm going to apply the power squared. So power to power is 4, power 4. It doesn't affect the root. This is divide, because it's negative, but I'm just going to keep it as negative in the numerator. So power to power is 4 times 2. And it's the same cube root. And this is divide, so it's just going to convert that to a negative power. So I'm just going to show that as divide. And this is divide. Okay, so I can group my a's together. Base a's can be applied together. So I end up with a to the power negative 5 plus positive 4 is negative 1/3. I'm going to apply the power on b's together. So there's my base b. There's my other base b. So I end up with b to the power negative 8/3 plus negative 1/6. Now to add these together, I need a common denominator. And if I were to multiply roots together, root, cube root, and sixth root, all I really need to do is find a common root. Okay, in this case, the common root is going to be 6. So I can rewrite the b. Let's just make sure I keep track of the a here. So I can rewrite the b. That's going to be written as, instead of negative 8/3, I'm going to write that as negative 16/6. Now I have a common denominator, and I can add those exponents together. What really was happening here is I got a common cube root, sixth root for both of those. And then I can combine those together. So then this becomes a to the negative 1/3 this is b to the power negative 17 over 6. There's my answer. Now, since these are negative powers, although this is good enough, I'm going to rewrite this as 1 over a to the 1/3 b to the power 17 over 6. Okay, so there's my answer.